In this video, we're going to look at how to convert from moles to grams of a substance. And this is a really important thing later on because we need to be able to calculate how many moles of a substance there are if we measure it on a balance. And vice versa, we need to know, okay, if a chemical reaction is going to produce X number of moles of a substance, well, how many grams is that going to be? So these conversion calculations, we're going to use them quite a lot later on when we're doing calculations on chemical reactions. So remember, moles, this is our way of counting atoms, just like we count eggs or donuts in dozens. You know, you can go and buy 2 dozen donuts. If you have 2 moles of a substance, that tells you how many atoms you have. Okay, and this is again something that's going to be very useful later on. Now, doing these conversions, I'd say there are 3 different methods. And the first one I'm going to teach you just has to do with kind of the common sense reasoning. So mole to gram conversions. Okay, we're going to look at method 1 of solving these problems. So example 1, okay, 4.20 moles of, let's pick a substance here like calcium carbonate. Okay, equals how many grams? What is the mass of that many moles of calcium carbonate? So method 1 is just kind of working it out in your head whether you need to multiply or divide. Now, no matter what, anytime you see moles and grams, you're going to need to know the molar mass of whatever it is you're dealing with. So you should always start there because you know you're going to need that in the problem. So step 1, molar mass. And molar mass, remember, is how many grams is 1 mole of this substance. And that's the one where we go to the periodic table and we add all these numbers up. So calcium is 40.08 grams per mole. Carbon is 12.01. Again, I'm looking all this up on the periodic table. Oxygen is 16. We got to go times 3 on that one because there's a subscript of 3 right there. So 3 times 16 is 48. And then we're going to add all these numbers up. 48 plus 1201 is 60.01, and then this will be 100.09 total. Grams per mole. Okay. Another way to write this down is to say 1 mole calcium carbonate equals 100.09 grams calcium carbonate. Okay, so we're going to need this number in a minute. Now, how do we do our reasoning part here? Step 2. Okay, we know that 1 mole of calcium carbonate is 100.09. Just think this through. What if you had 2 moles? How many grams would that be? Well, that would be twice as much. That would be 200.18 grams. And if we had 3 moles, well, that would be 3 times as much, right? 300 times 0.27 grams. Okay? So then finally, what we're not looking for is 1, 2, or 3 moles. We're looking for 4.2 moles. So we know right away that we're going to multiply to get whatever number this is right here. Okay? So we just kind of thought it through, and now we're going to take 4.20 times 100.09. Grab a calculator. 4.2 times 100 equals 420.378. For sig figs, I'm looking at 3 sig figs right here, 1, 2, 3, and that's at my weak link, so I'm going to round this to 3 sig figs and just call it 420 grams calcium carbonate. And that's it. Okay, so that's method 1. I kind of prefer this method because once you get the hang of it and you start to recognize what to do, it's pretty quick. Method 2 is what lots of textbooks use. So when you read our textbook, you're going to see this method 2. And method 2 is all about using conversion factors. So I'm going to write that down because that word comes up a lot. So using conversion factors. Same problem, okay? Again, I'm still going to need the molar mass of calcium carbonate, 100.09 grams per mole. So I'm going to rewrite that right here. 1 mole calcium carbonate equals 100.09 grams. And whenever you have an equality like this, where there's one unit on one side and another unit on another, this is how you figure out the conversion factors that you have available to you in order to do this problem. Okay, so from this equality I can write two different conversion factors. I can write the one with 1 mole on the top, and that'll be 100.09 grams on the bottom. I can also write a different conversion factor where the mole is on the bottom. 1 mole calcium carbonate, and the grams are on the top. And now when I set up the problem, I can use either one of these in order to solve the problem, but I want to pick the one that will help me do the cancellation. Okay, so just like I showed you in a previous lecture, you want to start with what you know, what's given to you in the problem, and that was the 4.20 moles. That's what I gave you in the question. So we're going to start there, 4.20 moles. There's going to be a conversion factor right here. And then we want that to equal how many grams of calcium carbonate. Okay. We want to choose the conversion factor that's going to get rid of the moles. So since I have moles on top in the beginning, I need to choose this conversion factor right here because that's the one with moles on the bottom. So now 1 mole on the bottom, 100.09 grams on top. If I have moles on top and moles on bottom from algebra, that means it cancels. Moles divided by moles cancels, and I'm left with the grams. That doesn't cancel, and that's good because that's the unit that I want in the final answer. And what we end up with is 4.2 on top, 100.09 on top, and when they're both on top, we multiply. So essentially, method 2 is just a different way of thinking about the exact same thing. You remember here we multiplied, and here again we're multiplying. It's just a different way to write it down and set it up. If you like algebra and you're a math-minded person, then this is probably your favorite way to go. You're going to get the same answer either way as long as you know to multiply when you do that. Okay. Method 3. Method 3 is, you know that Stockinger gives open notes tests, and you can't remember anything that I just taught you in Method 1 and Method 2, and you know you're going to forget it. Method 3 is, use this page in your notes as a cheat sheet during the test. Okay? So for moles, 2 grams, sorry about that. Okay, because that's what we're doing here. We're starting with moles and we're trying to get 2 grams. If you have moles, 2 grams, multiply by molar mass. Okay, bam. Keep that in your notes. If you absolutely can't remember anything from Method 1 and Method 2 and you get totally stuck on a test, just come to this page in your notes and make sure that you can find it, because this is basically just telling you what to do. Okay? Good stuff. Let's go to a new problem. In this problem, we're going grams 2 moles. So now I'm in the lab. I did a chemical reaction. I've got some product and I'm getting how heavy it is, and I want to know, well, how many moles is that? I can measure the grams in the lab. Let's convert that to moles. So, example. You have 14.95 grams of calcium chloride. How many moles is that? Okay, once again, we have a problem with grams and moles, and whenever you see that, you're going to need the molar mass. Okay, I don't know how many moles this is, but I can figure out from the periodic table, well, how many grams is 1 mole, right? So, step 1, molar mass. And I'm just using my method 1 here. Okay, method 1 was just kind of reason it out. Think it through in your head to figure out what you need to do. So step 1 is I'll get my molar mass. Calcium was 40.08 grams per mole. Chlorine is 35.45. There are 2 of them. So I'm going to multiply that by 2. I'm keeping calcium times 1. This then is 70.90. Add them up and I get 110.98 grams per mole. Step 2 is to figure out the answer to the problem. Do I need to multiply or divide? Well, I know that this is how many grams are in 1 mole, right? Now, I have way less than 1 mole here. 1 mole is 110 grams. This is about 15 grams, so I know I have way less than 1 mole. What I'm really trying to figure out is, how many of these 110s could I fit into 15? And I'm going to get a number less than 1, right? Because I can't even fit a single 110 into 15. If I'm asking how many times will 110 go into 15, that's not even going to go in one time. And that makes sense. If I divide, I'm going to get a number less than 1, and that's what I want. Because this 15 grams is less than this, so that means I have less than 1 mole. Okay? So, 14.95 divided by 110, 0.98. A little sloppy there. Pull out my calculator. Okay, and if you're going to do this kind of reason it out method, you need to make sure that the numbers make sense. Again, this answer is a number less than 1, and that's what I wanted, because I only have 15 grams. 1 mole is 110 grams, so I have less than 1 mole, and this is a number less than 1, so that does make sense. So 0.1347. And I'm going to just stop there at 4 significant digits because that's my weak link right here. 1, 2, 3, 4. And I'm trying to figure out how many moles. And that's it. Okay, that was method 1. Method 2 is the same sort of problem using conversion factors again. My pen's being pretty sloppy today. So we write out our equality. 1 mole of calcium chloride equals 110.98 grams. I figured that out in the last page, and from that I can create 2 different conversion factors. I've got the one with the 1 mole on the top, and I've got the other one where the 1 mole is on the bottom and the grams are on the top. Now once I set up the problem, I'll be able to see which one of these is going to be most useful to me. I really prefer this method for these problems because it helps me from making mistakes. Like in the last problem, what if you put the 110 on top and the 14 on the bottom accidentally? Well, that would give you the wrong answer. This method, I think, helps prevent that from happening. So we start with what we know. What we know is we have 14.95 grams of calcium chloride. We know there's going to be a conversion factor right here. And we know that in the end we're going to get how many moles of calcium chloride. So again, I want to pick the conversion factor that's going to have grams on the bottom because I want that to cancel. And this top one has grams on the bottom. So I'll write that down. 1 mole calcium chloride with the 110.98 grams on the bottom. And now that I have a gram on top and a gram on bottom, anything that's the same on top and bottom cancels. I'm left with moles on top, and that's what I want. So now I've got 14.95 on top, 110 on the bottom, and that means divide. Take the top one first, divided by the 110 next. That's exactly what I did in the last page, and I got 0.1347. So that's my answer. Okay. Method 3 is use the cheat sheet. You can't remember anything. I'm going to add to my cheat sheet here grams to moles, divide by molar mass. Okay, and that's it. These are the only two things you're going to run into when you're doing mole and gram conversion problems. I've given you 3 different methods to use. I highly recommend that you just pick the one that makes the most sense to you, that works the best for you. You do not need to learn all 3 of these. Just find one that works and stick with it.